Hello students, today we're going to talk about clamping. So we talked about locating already, where we position the part in the right location. But today I want to talk about the second thing that we do, which is clamping, and that is holding the part against the locators. Remember, when we have a locator, generally the locator will only position the part and remove half of the degree of freedom. That's not totally true, or not true in every case, but in many cases just a single pin will prevent motion in one direction, but we have to clamp against that locator to prevent motion along the second direction of that degree of freedom. So let's talk about some basic principles of clamping. There we go. Now some basic principles of clamping. So one thing is that we just said that. I don't need to say that again. So our ideal conditions are that the clamp is directly opposite, you have a clamp directly opposite each locator, and you assume that there is no friction. Now in real life there is going to be friction, but if we start with the assumption of no friction, then we can end up with a more robust clamping scheme so that when friction is added and the reality of life is there, then the part is held better than we expected rather than not held as well as we expected. Do we do that in every case? No, this isn't ideal. So we sort of start at this point. And then the ideal is that the clamp must withstand the entire force that can happen during the process and not deflect at all. But of course, real things do deflect, and we have to be ready for that. So the reality that we have is that we can't always clamp directly opposite each locator. Sometimes we will have to just clamp where we can that won't be in the way of the process. But we need to still follow rules. We still need to have the line of action of the clamp between locators so that we're not imparting a rotational moment to the part such that when we clamp it, the part is trying to spin out of our locating system and come out of our fixture. We should always be considering the moments that we're applying with the clamp. What is that doing to the part? Is it working to deform the part? Is it working to remove the part from the fixture? Or is it working against the forces that are being imparted by whatever cutting process is there, or measurement process, or assembly, or whatever it could be in welding, the stresses that you get from the shrinkage of the part after it's been welded. So sometimes we do have to rely on friction. If you think back to your time in 332, almost every part that we made in that class we put in a vise. And a vise is very dependent on friction because we're not clamping in every direction. We're clamping in one direction, just that one direction. We put parallels underneath the part to remove half a degree of freedom, and then we clamp it in the opposite direction, and we're eliminating, hoping to eliminate all the degrees of freedom just with the bottom support and the back fixed jaw. So we haven't eliminated all the degrees of freedom very well, and we're completely dependent on friction for it to work, and that's why parts come out of vices sometimes. So we really have to be careful about that when setting up a vise and thinking about how the process is going to happen. And then we need to be careful of part deflection, especially if we're putting in something that is too difficult. So as we look at this part right here, you can see that the part is this little white thing in the middle, and it is being centered on this plug and then supported by these three rest buttons. They're locating buttons, which are just a rest button or a locating button is a piece of hardened steel. Generally it's fixed on a dowel, so it would be down into the jig. And then we have clamps that are directly on the top, directly opposite those rest buttons, those locating devices. So this is great. If you can do this in an operation, that's fantastic, but we can't always do that. So we have to think about the force that we are dealing with here. So we need to hold the part against the locator We have to resist any loads of the part from the mass of the part or the way that the part wants to move on its own, and then also against anything that the process imparts. We need to consider the direction and the magnitude of those forces because they really matter a lot. If we're only going to be applying the force one direction in the process, then it's a lot easier to position the part and to locate really well so that your locators resist that direction. However, we need to be really careful about that because sometimes we consider things and we don't consider them fully. So one example is drilling. So drilling applies a really hard force downward as you're drilling, and it is putting, as the drill turns, it is putting a huge torsion on the part in one direction. And so sometimes people who are creating drilling fixtures will make them so that they only really resist that downward force and the torque in that one direction. The problem is if you drill down for a minute and then you pull the part back up, when you pull it up there can be burrs on it, or just the drill can get caught on the chips can jam up the hole, and so there's actually a pretty good lifting force when you pull the drill up out of a part, or if the part shifts at all it will be rubbing against the cutting edge. And so there's a big lifting force. Now the torque continues to be in the same direction, so that's still a pretty good thing that you can do, is just to put locators to resist that direction of torque because the direction, it's still turning in the same direction. As long as you're drilling. As soon as you start to tap, then you put torsion in both directions, and that's no longer true. But when drilling, you have a huge force down, but you have a non-insignificant, which would be a significant force, upwards when you retract the drill. And so things like that are really important to remember. Okay, here are just two graphics of something like that. If you were using a tool that moved across in only one direction, then we would want to put the locating side of the fixture to resist that force, and then we would clamp against the locating side. Why would we want to do that? Well, if we do it the other way, where we have the locator over on the right side of this picture, and this tool comes through and is putting a force across, this clamp now, to keep the part in place, has to overcome both the whatever force it took to have enough friction to keep the part in this fixture, plus it has to have extra force that's imparting to overcome the tooling forces. And so this clamp is now doing much more work. Why is that bad? Well, if this sits there with twice as much clamping force, then you have a much higher chance of deforming the part or indenting the part. This is also shown down here at the bottom with just a turning tool instead of a linearly moving tool. Now, this works in some situations that you can resist that single direction of force. But with a lot of use of CNC machines and more modern processes and controllers, it's more likely that the tooling force will come from a bunch of different directions. And so very often we have to be prepared for the tooling forces to come in any direction. But a good analysis of that will help us to understand. We have to make sure we're not going to deform the part or change the part's dimensions by the way that we clamp it. If we have thin walls, or if it is a large part and we clamp it, we're not able to clamp on the locators for some reason, then we have to make sure that we're not deforming the part. We want to minimize our damage to the part. Anywhere that we're clamping on it, we have the chance of indenting it or bending walls. And then we need to watch for cutter pinch. So I don't know if you've ever experienced cutter pinch, but cutter pinch is where our clamping forces seem good at the beginning, but if we do something where we machine some material away, we very much weaken the part, and it will actually, as we go along, it will be deformed in by our clamping force, and it will cause it to grab the cutter or whatever we are doing in that process. So this happens a lot on saws, and it can happen in the in a CNC machine as well. Okay, so two quick thoughts about this. One is that in real life we don't have the force coming from just one direction. As you look at this tool would be going around the outside, so it is applying forces in all directions. We'd have holes drilled here, so it would be applying big forces downward. There probably isn't a big lifting force on this part, but that's about the only force that we don't have on this part. And there could be a lifting force depending on tool geometries that we chose. Also, if we have a part where we're machining way down deep inside, we have to be careful about over clamping it and causing it to have some amount of deflection. Let's look just a little bit at how we might do some clamping. So this again is the part that we were looking at the other day. We have three locators here on the A datum, 2 on the B datum, and then 1 on the C datum. Here's our part, and remember we were using this to measure these different holes that are on it. But let's say that we wanted to clamp this in place. So ideally there are the 3 locators down there. Ideally we would come in and we would clamp downwards like this, so directly on top of each locator. And then we would clamp somewhere over here opposite these 2, and that could either be 2 clamps, one heading in with its direction of force going across and into the locator, or it could be 1 clamp that is in the middle like this, and its line of force happens between these 2 locators. And then a final clamp, so we have 3, 4, and 5 clamps would be directly opposite this one. Now on this side I do need to be directly opposite this locator. If I move down here somewhere, notice how, because there is not another locator on this side, when I push over here it can move. Now if I go in and I put in these clamps and I put in this clamp, this B clamp against the B datum, then I could push somewhere over here, and if I'm clamping hard enough against the B datum I won't be able to rotate the part. But if I do that, then I have to have some system that forces the operator to clamp things up in the right order, because if they clamp the A datum and then they clamp the C datum before they clamp B, it's not going to work. Also, it is just better practice to make sure that the line of force from your clamp is going through a locator, unless you have 2 and then you can go between those 2 locators. Why can I go between them? Well, when I push right here, I'm creating a moment about that goes this way around this locator, and there is a moment that goes the opposite direction around this locator, and those 2 cancel each other out. So it's okay that I'm not pushing directly into the locator. Here I need to push directly towards the locator, because if I push anywhere else I'm imparting a moment that can remove the part from the fixture. Okay, so that's ideal. Let's say that we have, sorry, made a little earthquake for you there. Let's say that instead of this, or instead of the outside edges being the B datum, maybe this center pin is the B datum. So now I have something where I probably over constrained it because I removed 3 degrees of freedom down here, and if this is tight I have removed 1, 2, or 4 degrees of freedom from by using this big center pin, and that depends on the how tight it is between these 2 and remember how far into the part we go. So we've sort of removed 4. So And we have 3 originally and 4 here, so this is way over constrained. So this is not a very good way to do it. But if I had this as the system, how would I clamp it? Well, I would want to clamp down on those, on the flats on the other side, and then I would need to clamp somewhere to prevent it from rotating. And if I clamp in one place, you can see that's not a very good way to prevent it from rotating. If I clamp out here, that doesn't do it either. I would, remember, have to put in a locator to keep it from rotating. We call that clocking, and then I would clamp against that clock. So 3 clamps right here, and then 1 to the side. That would be another way to fixture this part, and it just depends on what the datums are. Okay, we're going to look next at some different types of clamps, and then in class we'll actually evaluate some different clamps for ease of use and some other characteristics of them. All right, thanks for watching.